This is chapter 4, 77. So there's this car, it's going to roll down this cliff, and then it's going to fall off. And some of the given information is that while it's rolling down, it's going to accelerate at 4 meters per second squared. The angle the cliff makes with the horizontal is 37 degrees. The cliff is 30 meters high, and the ramp distance itself is 50 meters. Okay, so let's focus on just rolling down the ramp first. So I'm going to be interested in the final velocity. So I'm going to use the v squared equation. So the final velocity squared, the original velocity was just 0 plus 2, and it's going to accelerate at 4 for a distance of 50. Okay, so this is just 200, the square root of 200, excuse me, this is 400, the square root of 400 is 20. That gives us the final velocity of 20 meters per second. Okay, if I wanted to know the time, well, realistically, it's going to accelerate from 0 to rest in 5 seconds. Think about v equals v naught plus at. So it got up to 20. It started at 0. It accelerated at 4. For how long? Okay, it took 5 seconds. If we needed to do that, we could do that, or we even could have used x equals 1/2 at squared to describe that. It went a distance of 50. 1/2 times 4 times what squared? It's just the square root of 25, which again gives us 5. So either one of those methods could have found us the time it takes to fall down the ramp part. Okay, now let's focus on the cliff. So now we're in kind of phase 2 of this motion. Now we're in a projectile motion. Forget anything about the ramp. We know exactly how fast it's going and what angle it's going to leave this with. Again, it's kind of thrown, it's like it's thrown down almost. So if we write our standard position equation out for projectile motion, and x equals v naught cosine theta t. So what we want to do, we want to figure out when it hits the water. So if it hits the water, it's going to have a y value of 0. It's going to be a starting height of 30. It's down. Again, that's a negative sign because the car has a vertical velocity that's going down. How fast? Well, 20 sine 37 t minus 1/2 9.8 t squared. And at this point, that's a quadratic. You can solve on your calculator of 1.53 seconds. Okay? But if it went 1.53 seconds, well, how fast was it going horizontally? Well, 20 cosine of 37 was its horizontal velocity times being in the air for 1.53 seconds. Again, this is just horizontal velocity times how long it was going that velocity gives you 24.4 meters. Okay? That's a total time then of 1.53 plus 5 of 6.53 seconds from when it rolled down the ramp and then went off the cliff. If we want to find the final velocity, we need to know, again, it's this picture I'm going to draw almost every time. I need to know horizontally how fast it's going and vertically how fast it's going, and then I'll use the Pythagorean theorem and inverse tangent to find the angle and the length of that vector. Okay, Vx is a constant, right? It's never going to change. That was 20 cosine of 37. That's some value. That is like 15.97. And then Vy follows our standard velocity equation from like the first week of school. How fast we're going vertically is how fast we were going originally, negative 20 sine 37 minus 9.8 for how long we were in the air, which was the 1.53 seconds. Again, make sure that's a negative because you were already going down, and then of course gravity was pulling you down, and you should get somewhere really close to negative 27. And so those are those two values, 15.97, 27. If you do inverse tangent in the Pythagorean theorem, you should get a final velocity of 31.4 meters per second going down at an angle of about 59.4 degrees, and of course that is below the horizontal.